Okay. Let's try this again. But I think, how many of you have watched the videos afterwards? After class? A couple of them. Does it help with reviewing parts of the class that you didn't learn, or?
Yeah.
Okay. So it doesn't help. That's fun to do anyway, so. But I think it helps, so certainly I'll look like after class, and I'll see five or six people watching the live stream. So again, that's what I just want to make it available so that when you can't be here, you can be here. And if you miss something in class, you can come back and get it later. Okay. Algebraic expressions. I'm going to go to the student workbook. And we're going to just go into the workbook. And sometimes, I know that I go through it in class and then you go later and then you can't remember how to get to where I got to. The video might help you seeing where I'm at. Yes?
I have a question on one of the problems from Unit 1.
Okay.
Is it okay for you?
Or
do you want to wait? Let's wait.
Why don't we go through this and then we'll go back through this, yeah. Okay. Now that we've got this working, I don't want to. Okay. So, when we add two things, what is it that we need? What do we need to be able to add two things together? So what's a like term?
In the first problem on the left, they all have a, meaning you can simplify the entire four concepts of it.
Okay, so the
As
A.
opposed to if the last one were B or C.
Okay, so they have to be the same thing. So my question is if I go to add, can I add these two things together?
No.
Why not?
It's not the same.
Not the same. They're not like. Okay. Can I add these two things together?
Yeah.
If I call them pins, one's red, one's black, I know they're a little different, but they're both pins, so I can add them. 1 pin plus 1 pin is 2 pins. Okay. But a remote and a pin, I can't add them. They're not like items. Okay, so I want you to visualize something like that, because otherwise the abstraction of, but yes, in math it's going to be a different letters are different terms. Okay, different, not like terms. So let's go ahead and take a look at a couple of these. So in this one, the variable parts are all the same. So you can almost replace the A with an apple. We've got 3 apples. We take away 6 apples. We add back in 10 apples, and then we take away an apple. So how could we do the math to figure out what we have at the end?
Could you add like both the positives together? And both
Sure. And that's one of the things that I like to think when we're doing algebra, if we think of every subtraction problem as adding the opposite, what that does is it puts the negative sort of onto the term itself. And over here, we'll think of this as adding a negative. And then addition we can do in any order. And that's a good way to structure it, is let's just add all the positive stuff, add all the negatives, and then we just do one subtraction at the end. Okay, so I would do it that way. I would take the 3A and the 10A. Let's add those two together and get 13A, 13 apples. Take the negatives. These are maybe like what we owe somebody. We owe somebody 6 apples. We owe somebody else 1 apple. So that's a total of owing how many? 7 apples. And then we could do the subtraction at the very end. 13 minus 7. We now have 6 apples left. 6 A's. Okay, so see, the like term is a thing, and it's you treat it sort of as a name. Yes.
So just that variable a by itself, that just it means it's a 1.
Very good, and that's one of the things you have to see in algebra. Yes, a really is equal to 1a, and if it's helpful, and it was for me in the beginning, to write that 1a in there, to write the 1 in there, because it reminds you that yes, there is always a 1 there. There's always a number in front of the letter. It's just when it's not there, it's because it's an invisible 1. Okay, so you don't see it. Good. So how about these middle ones? Which ones are the like terms?
5 and 6.
You've got a 5x
And a 3x.
and a 3x over here, or negative 3x. So yeah, so you're looking at the variables, the letters. How about the middle, the y, the 10y, and the 6z? No, they're, so, but we can combine the 5x and the negative 3x. Again, a lot of times I think of this as adding a negative 3. So when we combine 5x with a negative 3x, what do we end up with? 2. We've got 5, basically take away 3. 2 are left. 5 take away 3, so we can combine these two. 2x. But we can't do anything with the 10y, so we just write it down. Can't do anything with the 6z because we don't have any like terms to combine it with. So we just write it down. That's our final answer. That's maybe the hardest part of the lesson, is figuring out when you're done, because you feel like you want to do more, right? Because that doesn't look all that simplified, but that's all we can do, is we can only combine either with addition or subtraction terms that are absolutely alike. Good. So far, so good? Okay.
So you don't want to always find the like terms.
Yes. Now this last one gets into maybe a little bit of complication because we see a lot of n's here, don't we? But are all the n's the same? Let me come up here a little bit, and what would if x was a line like that, what would x squared look like physically? 2 lines, but it actually, x squared is x times x, and when you multiply, and the reason we call it x squared is we actually have a square. Okay, so physically, when you have x squared, you've got a square. When you have x, you have a line. Is a line and a square the same thing? No, physically they're different. So this is how you start to visualize something that's very abstract. What about x to the 3rd? What would that look like? Very good. That's why we call it x cubed as well. It's actually, I know I got a little bit smaller, but I was running out of room. Let's see if I can draw this. It gives us a 3-dimensional cube. So is an x squared and an x cubed the same? No, physically they're different. X cubed is a cube, x squared is a square. So as you look at variables, when you start to see the exponents actually create another dimension. And the x to the 4th would have 4 dimensions, and sorry, I can't draw that, but and I don't know what the 4th dimension would be. But so each of those terms is different. So where are the like terms? 7n, and here's, remember there's the invisible 1 here. So we can take 7 plus 1 and get 8. 8 what? 8 n's.
For the 3a and 6a, there's always a 1 in front of a, right? Is that why? You get 7a?
Yeah.
He's talking about the 5.
This one here?
Yeah.
Yes, back here.
There's
So that,
always
yes,
a 1 in
there's
front of it.
always
That's
a
why.
1.
Okay.
Right. So that was a minus 1a.
Okay.
Exactly. Okay, and so then we can come here. Let's go to orange. And then the squareds are like terms to each other, right? So I've got 3 of them and 8 of them. So I can combine them. 3 plus 8 is 11, and what are they? They are n squared. So notice the variable part doesn't change. That's sort of like a name of saying what it is. Anything else?
Cube.
The cubes. So we'll indicate those with this and this. And again, remember, this is a -1. So a -2, 1, and a -1, when we combine those, what do we have? -3. And -3 what? N cubed. Okay. Now this is a perfectly fine way to write it. However, a lot of times it's rewritten with the biggest exponent at the front. So you might see it also written as -3 n to the -3 n cubed plus 11 n squared plus 8n. Okay. Yes.
But is the 3 squares, is positive? It's not positive, it's not -3.
Well, the negative comes from here. So the coefficient, the number in front is negative, and it doesn't. Yeah, the exponent can't affect it. Does that make sure?
So it's not negative. Negative is positive.
If you're multiplying, oh, I see.
Okay.
So yes, if we had -2 times -1, that would end up being +2. But what we had was -2 subtract 1, or if you want plus a -1. In this case, when the signs are the same, we add them, but it will take, since they're both negative, we got more negative. Okay. And the way I always think of this one is if I borrow money, that's negative, right? I owe some money.
Mhm.
If I borrow more money, have I paid off anything? No, I'm going deeper and deeper in debt. I'm becoming more negative. Okay, so that's good. That's getting at those principles of what to do with positive.
Does it matter what order? Like, do you have to put the -3 n cubed plus 11?
No,
Okay.
but a lot of times you'll see the answer in the back will do that. Occasionally, Math-AS used to say put it in orders, but a lot of times they've got it now. It'll take it in any order. So I just want, it'll all both give us, all of them will give us the same answer. Okay, so let me go ahead and save this page. And so far so good? Okay, I'm going to clear off this screen. Actually, no, I'm going to go to a new page. So it actually, if we need to go back, it remembers where we're at, or it remembers the previous pages, so nothing ever gets erased. That's what I think might works out good with this is, I erase the board, it's gone. Here I just have to go back a page and go forward. Okay, so again, some more examples. Let's see. I'm just going to scroll down a little bit. Anything you feel comfortable about like terms? Anyone want to see? Okay. So now we're going to talk about something called a distributive property. So what I'd like to start off with is a physical example. Let's take 2 times the quantity 3 plus 4. Now we know, how are we supposed to work this? What are we supposed to do first? Parentheses first. So we would take 3 plus 4, right? And so that should give us 2 times 7. And then we do what next? Multiply 2 times 7, 14. No problem there, right? Okay. Now, what if I, for some reason, wanted to say, well, let me just play around. What if I wanted to multiply first? And I want you to be careful for just a moment. I'm going to do something that's incorrect. So I want you to know it's incorrect before I do it. And we'll see that it's incorrect. So but I'm doing this on purpose because maybe you would try this. Let's see if we could multiply first. So what I'm gonna do is I'm gonna say, let's take 2 times 3, that's 6, and then add the 4. Did that work? Well, 6 plus 4 is, I didn't get the same answer, so that must not be right. Well, let's see, maybe I should multiply the other one first. Maybe if I took 2, 3 plus 4. What if I took 2 times 4 and then add in the 3? That gives me 11. I'm getting closer, but still not right. So what do you think I need to do if I wanted to multiply first? Maybe times them both. Let's see if that works. So let's take it times the first one and the second one, and let's see if it gets us to what we know it's supposed to be. 2 times 3, 6. 2 times 4, 8. 6 plus 8, 14. We match the number we know from the way we correctly worked it. And so the reason I do this is because when we come to variables, can I do anything in this example, 2x plus 4, can I do anything with that? We just talked about it, they're not like terms. I can't add them. So if I'm going to do anything, I've got to do this multiplication over the addition. But now I've got to think about how could I do that. And I'll tell you what, a lot of students have told me, they see this 1, 5, so they think they should only have to multiply once. Doesn't that sort of make sense? It made sense to me at a time, but we did it up here. If we only multiply once, we don't get to the right answer. The thing is, with a variable, we wouldn't see that it's not the right answer because we don't get a number. We can't check it because we've got this unknown part. It's like a clog in the drain. We can't get to the end. But when we do it with numbers, we see that the process has to involve multiplying by both the terms. Okay, because we put in numbers, we know we can get the right answer. So we know that up here, the only correct way to do it is to multiply by both the numbers, both the things in there. Okay, so when we come down to this example 1, what do we want to do with this 5? Multiply it by the 2x and multiply it by the 4. We got to multiply both by 5. And so sometimes we do this, it's like a marker, so that 5 is, while there's only one 5, those parentheses are saying that it's got to apply to both.
So we multiply both by 5?
We multiply both by 5. And I'm going to write this out. Now, a lot of you would do this in your head. You'll just take 2 times 5 is 10 and write 10x, and that's perfectly fine. I'm going to take one extra step and say that the first thing we do is we take 5 times 2x, and then we're going to take 5 times 4. So multiplication is distributing over addition. And then 5 times 2, that gives us 10x. And 5 times 4, that gives us 20. And that's our final answer. Okay. But do you see how coming back and relying on concrete numbers to work with really verifies the process for us? So a lot of times in algebra, that's what we have to rely on, is that the process we use is correct. Yes?
Well, if you added the 3 and the 4 together first, and you got your 7, you are technically multiplying the 2 times both numbers because you had a 7.
Right.
You added the 2 together.
Yes, exactly. And so then in the situation where we can't add them, then we definitely want to do it. Right, because it's multiplying by the sum. Good. And a lot of times you'll see, and you'll see the patterns that work, and that's really what algebra has done. It takes processes that work again and again, but we can always verify them when we put in a number. Now in this lesson, we're not putting in numbers because we don't have the equal sign. When we get to lesson 3, we'll have an equal sign. We'll actually be able to solve for the variable, then plug it back in and see if it's the right answer. So 3 is actually the next lesson actually gets a little bit easier because we could go back and check our answer. At this stage, we don't know what x is, so it's really not, we really can't check. Okay. You might, actually I always say that and then some student finds a way to make it work. And I said, oh, that was interesting. Yeah, it does work. So, but that's basically what we have to do. Okay. So far, so good? Okay, let's go here. I'll save this one again. And then what I'll be posting is these as little pictures as part of the notes if you want to. Again, if they're helpful, great. And as long as they help one person, I'll keep doing it. Even if it only helps one person every once in a while, I'll keep doing it. Okay, let's get a new page. Here we are. And let's scroll down a little bit more. Okay, so now we get to some, did that one. Any of these look interesting?
About, for 3, did you just,
Okay,
is
good.
that just a negative sign? Like it's-
Good. Yeah. So we'll,
Just be negative 5x4 plus 8.
good. So, but this is the one actually that causes sometimes the most problem. What you might want to think of it as, instead of just being a negative sign, thinking of it as being what?
1.
A negative 1. So what we're going to do is we're distributing and we're multiplying everything by negative 1. And don't think too hard, because when you multiply by negative 1, what happens?
2 negatives turn into 1.
Good. The signs will always change because 2 negatives become positive, a negative and positive becomes negative. So really all that's, and the numbers aren't going to change because when you multiply by 1, the numbers stay the same. So negative 1 times 5, and again I'll write it out, negative 1 times 5x to the 4th, and then we'll have a negative, this is hard, how do we write this? Negative 1 times a negative 8. So a negative times a positive gives us a negative 5x to the 4th, and a negative times a negative, positive 8. So notice how it just really changed the sign. The positive became negative, the negative became positive. Okay. But that's one of the ones, for some people, that's going to get you again and again. But just that negative sign has to distribute. So far, so good. Awesome. So okay if we skip 4? Yeah, everyone wants to do it because it's fractions, right? I always say don't worry too much, but the difficulty of this is not is the fraction parts. But yes, we could do that. What do we do with this number in front, this 2/5?
Switch it.
No, we just multiply, right? We just distribute it to each of these. So I'm going to show you that this is really no different. It's going to be 2/5. That number 2/5 is just a number. You could turn it to decimal if it's easier to work with. That's another way to do these things. Turn all the fractions into decimals. Times x over 4. And then I distribute it to this one. I'll put the negative sign. 2/5 times 1/3. And when we multiply by fractions, what do? Straight across. Now this is one, if we're dividing, we flip the second and multiply, but this is where you might have forgotten the rules, or you want to start flipping fractions because it's fun or something, but yeah, when we multiply, we just do straight across. Okay, so go to blue since we got red. So we're just going to multiply straight across here, straight across here. What's 2 times x? 2x. What's 5 times 4? 20. Over here, what's 2 times 1? 2. And 5 times 3. That's pretty much it, except what can we do with the 2 and the 20?
Reduce it.
We can reduce because 2 goes into 20, 10. So we can write this as,
110?
good, x over 10, which is 1/10, minus 2 over 15. Now, do we need to get a common denominator to add these together? Yeah, if we were solving, we might want to do that, but they're not like terms, so we're not going to do anything with them. We can't add them, so just let's go ahead and stop. Not too bad, was it? Okay. Also, you could have, some of you might have taken a shortcut up here, right? When you saw the 2 and the 4, what could we have done? Cancel, right. We could have canceled the 2 with the 4. That turns that into a 2. And look, we would have got x over 10. Okay, so another way to do it, whichever you become comfortable with. And we will do a few things with fractions, but we'll do a lot of things without fractions because we want you to understand just this concept of distributing. And sometimes you put the fraction, it's all the things that go with fractions that get you hung up. Okay. That's why. Okay. Let's take a picture of that. We'll put that down as page 4.
These are getting uploaded to the notes. Whatever.
They will, yes. So if I remember correctly, but yeah, they're getting saved as JPEG images, as pictures, and then along with what I will do is I will put a link to the live stream, which thanks for the call, we'll have audio with it now, and there'll be the attendance quiz. Of course, the word of the day was I already achieve. Okay. Thinking of earlier in the day, they had pizza. So some people choose food. It was right after lunch, I guess. So we have achieve. So you'll do that. And then I'll put these notes as well as in links so that you could just click on them and see the pictures. Okay. So we'll keep doing that. And then we just kind of scroll through this thing. And again, this is the mini lesson. And a lot of these examples have also been worked out separately by someone else, and sometimes they might take a slightly different approach or a way of explaining it. And I encourage you to take a look. That might be helpful. Okay. Just more of it, right? Just more examples.
And if it's just one big number like that one was, you just add a 1 under it, right?
Which one?
Number 6, 6x, you could add a 1 under it, correct?
Correct. Yeah.
Okay.
Good. Everything is a fraction. If it doesn't look like a fraction, just put a 1 underneath.
Oh, I remember.
Yeah, divided by 1, and you've all of a sudden got a fraction. Good. Does that make sense? You guys want to see that one again, or we okay? Okay. Try not to do too many fractions because it just, I don't know, tend to cause a little bit of stress. I don't know about you, but it does for me. Okay. So now we get into this situation where we're just going to simplify algebraic expressions. And it's really just taking everything we did, but making it more steps. So we just have to slowly go through each of the steps in order, using sort of order of operations. So I'm going to start, we'll work a few of these. This one has a parentheses inside of a parentheses, so they use brackets, and sometimes that gets confusing. But what we'll see is when we have multiple parentheses, we just work from the inside out. We'll kind of take our steps through it. And then we've got a few fractions down here. So actually, before I get writing, I'm going to move this up a little bit more so I have a little bit of workspace down there. In fact, yeah. There we go. So what we're just going to do is called simplifying. So we'll take this A part. So what do we need to do with this 3?
Multiply it.
Good. Multiply it by what? So we distribute to both of these. Okay. And before I do it, I'm going to just think about, just like a good chess player, always thinks about what the next move is, or 2 or 3 moves down the road. That's why I'm not a good chess player. I have a hard enough time thinking about my first move. But so then what's going to happen here in the middle?
There's a 1 there?
There's a 1 here. And what I get you to think of is, think of this as instead of a subtraction, think of it as a plus, and then just put a -1 here. Distribute the -1. And there's going to be a plus sign left behind there, and that'll help. A lot of times it makes it easier. Oh, we'll distribute the -1 to the first term and the second term. Okay, so what does it look like here?
-6x.
-6x, and then -3 times -4 gives us a +12. Very good. I'm going to put this plus from the middle because there's got to be something there. And what I do is, if you don't, sometimes I've seen students that make that into multiplication, but it's not. It's an addition here. We've got -1 times 3x, -3x, and I'll put it that way. So I could have left it as a negative, but I like to do it this way. -1 times +8. So I can write that way. And then we can combine like terms, right? Where are the like terms? Okay, the x's are like terms, so we got a -6 and a -3. When you combine them, what do we end up with? We got more negative, so it's negative. We add them, and it's negative. How about the 12 and the -8?
12 minus 8.
So we have plus $12. We pay off a debt of 8, and we're left with plus 4. Good. I was going to say 3 for some reason, but 4 is a better answer. It's the correct answer, right? Are we done?
Yeah.
How do we know we're done?
It's jam.
No more like terms. Good. So that's what we're doing. When we simplify, we get it down till there's no more like terms. When everybody looks different, we're done. Diversity is great, right? That's what we're looking for, diversity. Okay, so far so good? Okay, so let's come over to B. And again, these are, you'll be able to see these examples worked out as well. Where do we start? Brackets, and kind of there's a bracket within a bracket. So this is so we start sort of within the inner bracket, right? What's going to happen to this x minus 5? Okay, good. There's a -1 out here that has to distribute, first of all, to both of these. And just like the last one, this is where I'll see the problem. If I take this negative and make it a plus, make the 1 a -1, 3 bracket 2. So nothing's been done there. I'm going to distribute a -1. So that's a minus x. Negative times a negative is a plus 5. Okay, but notice nothing else has changed. So far, so good on the inside. Now we could just write this last part down and deal with it later, but it's really 2 different pieces, isn't it? So we could also say that this is a plus and a -1. So we're distributing a -1 again. And again, when we distribute a -1, what basically is going to happen to the expression? Swap signs. Positives will become negatives. Negatives will become positive. So again, if you think in that terms, we'll get a -4x plus 10. Make sense? Okay. Now we could go ahead and distribute this 3 to each of the 3 terms, but what else could we do inside these brackets? There's some like terms in here. There's a 2 and there's a 5. That would give us 7. So I'm going to go 3, and then watch what I'm going to do, some magic. I'm going to turn brackets into parentheses. Is that legal? Because I'm the teacher, right? Well, you can do it too. Brackets are just another type of parentheses. They just use them because to differentiate. You could have made them all parentheses, but usually when it's typed up, they'll do it that way. And then I got -4x plus 10 because there's no like terms that I can combine yet, right? There is this like term of an x, but it's inside of parentheses. I got to get it out. Okay, so far so good. Questions? And remember, if you have a question but you don't know what it is, that happens. Sometimes the question is, well, I don't know what, but please explain. I don't understand. Okay, so sometimes we just move forward and we'll understand, but don't let me go too far ahead if you're not understanding. Because you're helping someone else who's watching through this video who can't speak right now, and they're just hoping that you would ask a question. Please, somebody ask this question. So you ask it, and then, okay. So far, but we're doing okay. What's our next step? We got to get rid of the parentheses, and we do that with distributing because we can't do anything else inside. No more like terms inside. So we distribute the 3. 3 times 7, 21. 3 times negative x, negative 3x. Parentheses are now gone. Negative 4x plus 10. And this stuff just keeps dropping down. So a lot of times, give yourself enough. That's why they do these workbooks. They give you lots of white room, white paper room, so that you can write and organize. Because sometimes I've seen it. I've worked with students, and they'll be in a workbook where there's not much room, but if they write on scratch paper, they solve it just fine. And it's just a matter of having enough room to work. So give yourself whatever room you need. Okay, so what do we combine? What are we combining? Okay, the numbers go together, so both are positive, so you can just add them, and then we end up with 31. The x's, both are negative, so what do? We add them. 3 plus 4 is 7, but it's a negative 7 because they're both negative, right? The sign of the numbers. And that's a perfectly good way to write it. What's another way we could write it? This is also a perfectly good way to write it. Notice the negative sticks onto the 7. So if I'm going to switch the order, I just have to keep the negative on the term it was on. And that's good practice to get used to. I can't just switch the 31 and the 7x. I have to keep that negative with the 7x. Make sense? Okay.
It's always like this minus 7x first.
It doesn't have to be, but it's that's called convention. Just says put the variables first, and then put the bigger variables first. So if I had an x squared, I'd put that first. Usually, doesn't mean it's wrong the other way. And a lot of times, with a lot of books, they don't like to have this negative sticking out front, so they do write it 31 minus 7x. Just simply because it looks prettier this way, actually. I think, yeah. My preference is this one, because when you put this negative on the front, it's so easy to leave it off or do something with it. It's in between, it's a little bit nicer, I think. Okay. So what if I told you these ones with the fractions, we've actually already sort of done this principle, but maybe you don't feel we have. So if I wrote this, so let me take this, we're going to take a look at C. So if I were to take 8 minus 5x, and I were to put a 2 out front like this, what do I do with that 2? Distribute it. Perfect. Which means I take 2 times 8 and 2 times negative 5x. No problem there, right? So what is C? C is a little bit different. I'm not multiplying by 2. What am I doing with the 2? I'm dividing. And what is division in relation to multiplication? It's the reverse of multiplication, but it's very related. It's just the opposite. So what I actually am doing, if you want to think of this, put a parenthesis around here, I've got to distribute this 2 to both of these terms. But I don't multiply them by 2, I divide both of them
That's
by
if they're
2.
a fraction.
It's a fraction. So really I'm making 2 fractions. I'm going to take 8 divided by 2. And then this little sign in between them says to subtract 5x divided by 2. Can I reduce either of these? 8 divided by 2, that's 4. So I'll write that as 4. 5 and 2 don't reduce, so I'll just leave it as it is. So now it's 4 minus 5x over 2. Can I go any further? No, so that's why I circle it. It's done. No like terms, and it's sort of simplified. Again, in algebra, when we have an algebraic expression, it's always really the same thing. We haven't changed its value, we just changed how it looks. We're doing a little bit of cosmetic surgery if you want. And I don't know, I think 8 minus 5x over 2 is maybe just as pretty as it gets, but it's the same thing as this. So a lot of times with algebra, we're just changing how it looks. And again, some of this is just building skills to be able to do this, and you don't know why we're doing it until we get down the road. But when we get into 3 and 4, we'll see that, you know, dealing with it this way might be helpful to break it into pieces. Okay. But so far so good, really. Just when we have a fraction, we distribute the denominator just like we do if we're multiplying. We distribute division just the same as we distribute multiplication. Okay. Let's take a look at this side. Can we just distribute this negative 6 through? We could, but what should we do first? The parentheses part, right? We've got this stuff here, and so how do we get rid of parentheses? The thing in front is multiplied, so we're going to want to first distribute the negative 3. Okay. So far, how's the screen working for everyone? I think to me it works better because these markers, sometimes they're pretty light and they're hard to see, and these markers seem to be always nice and dark. Okay. So then what we end up with, again, a lot of times in algebra, we're just rewriting things that we don't do anything with, right? The negative 6 we didn't do anything with. The 9 we're not going to do anything with. The negative 3, though, we distribute. Negative 3 times 2 gives us what? Minus 6x. Okay, so that's combining. So we have negative 3 times 2x. And then we take negative 3 times negative 5, a plus 15. So negative 3 times a negative 5, and that's how we got that. Anything we can do to make the top a little bit nicer, simplified? Good. Like terms here and here, we can combine them. And so we go ahead and do that. 9, positive 9, a positive 15 is going to give us a positive 24. And again, we could put it at the end or the beginning. Since we've got a negative, I'll do it this way. And then now what do we do? Divide. And what do we just divide one of them? Both of them. Okay, so same thing we did with distribution. If we're going to distribute, we've got to be fair. Okay. You don't give one of your cousins a nice ice cream cone and then let the other one, right? You got 2 cousins, you got to have 2 ice cream cones. Okay, so it's the law of nature, because they'll get big and they'll get back at you. You know, one of them will. So what we end up with is 24 divided by negative 6 minus, I take the minus from here, 6x over negative 6. 24 divided by 6 gives us what? And yeah, positive divided by negative gives us a negative, and that's going to be 4. 6 divided by 6 is 1. A negative times a negative here is going to give us a positive. And what's left behind? Just an x. So that one actually simplifies to a nice little simple negative 4 plus x. Or what's maybe a prettier way to write that? X minus 4. Again, they both mean the same thing, but this is one, move the x to the front and have the negative in between. Either one will work. So that's a simplifying thing. So sometimes we see that actually being able to apply these techniques does give us something that's simpler to work with. And again, when we get to lesson 3, we'll start actually solving for them. And if we can work with something simpler from the beginning, a lot of times it makes our job much easier. But that's what this lesson's about. Our lesson is not about solving. We don't get any real answers. We don't get a number. We just get more expressions. And we have to rely, but what it does is it gets us to rely on understanding the process that we go through. Order of operations, exponents first, or actually parentheses first, exponents, multiplication, division, then addition, subtraction. We're on to 5. Okay. Let's go through a little bit more, I think. And then again, we get to some more. You try some basically the same thing with just different examples. And then we get some applications. What do I usually say about applications? What did I say last time about applications? Don't remember? Maybe I didn't say anything. Usually the applications we're going to look at are, especially in these beginning ones, are more extensions. Like I said, they're good to work through, but don't worry too much about it if you made it to this slide. This is primarily focusing on the skills part. So everything else before this was skills. If you get that part down, that's great. If you get into the applications and feel like you're at the deep end of the pool and you don't quite know how to swim yet, go ahead and get out. I remember, well, anyway, yeah, you don't want to, it's not a sink or swim type thing. It's have some fun while you're swimming, but when the applications come, we'll have plenty of time to work through them. But I want to show you a few things that we can do, and that's what these applications are, is to give you a geometric look at algebra. Okay, so let's just see that this is really nothing different than what we've already done. Okay, but maybe if it's been a while, you might not remember too much about geometry. What does the word perimeter mean? Good. I like the visual. Did you see that? She said around the block. Okay, and I like to do it. I'm going to take a walk, so I put my little walking man. Going to go for a walk. The night security guard walking the perimeter of the building. And when you walk that building, what do? You walk one side, and you want the distance. You add the distance of each side, right? So how long is this side? That's all we can say about it. It seems weird because it's not a number, but that's what we got. Then what are we going to add when we come down this side? It's going to be the same length, so we're going to add. I'll put a parentheses around them. We don't really need them, but I just want to emphasize that's 3x plus 5. Oops. Where's my eraser? X plus 5. Then when I come along this route again, what do I get? Another 8x plus 2. Oh, minus 2, yes. And then we finish the route and come back to where we started. We add another 3x plus 5. And put it in parentheses. So what's the job to do here, really? Simplify by adding the like terms. So I see something with an x. And realizing that the parentheses are really not needed, I just put them to group those things together. So you could just drop all the parentheses, add all the x stuff. So 8x plus 3x plus 8x plus 3x gives us so 22x. And then add all the numbers together. Negative 2 and 5, negative 2 and 5. Negative 2 and 5 is 3. This negative 2 and 5 is 3. 3 plus 3, 6. There's our perimeter. Okay. But just it's kind of taking a algebra, putting it in what it, geometry. One more page and then we'll actually be in pretty good shape because once we make it to the applications, what does that mean? What's after applications? And have you looked at any of the lessons? What always happens after the applications? There might be a review, but there's nothing new. Applications is the end of the line. Okay. Yeah, you get into some review problems, which are good. Sometimes there's something called extension problems. And what are extension problems? Get you ready for the next class, not this class. So they're helpful if you want to. But again, if you can make it just up, I know you're all at different levels of understanding and where you're at. If you can just make it up to the applications, you'll be in good shape. If you can go through a little bit of the applications, even better shape, that's great. And if you get into the extensions, that's great too, but it's also just fine not to. Okay, it's not really my intention, but every once in a while I get a student who really wants to get into them, and I'd be happy to work with you outside of class because I don't want to cause too much stress for someone who doesn't want to get into the extensions, which is kind of me. Sometimes I have problems with it. I can work my way through them, but they are challenging. I tell you, if they're challenging for the teacher, they'll probably be challenging for you too. In fact, actually, I've had some students help me with them. And it just, yeah, I could get them, but they are designed to help you move along. Okay, so how about this as another perimeter problem? So what are we doing? Adding like terms, right? So part of it's just figuring out, this is 3x, that's 4x, that's 5x, that's 9x. So can anyone figure out what this must be? 14x, good. And then if we want the perimeter, we just add it all. So, oh, there's this little piece here I almost forgot about. What's this? 1x, because the total thing here is 4. This is dropping down to 3, so this must be a 1x. You don't want to forget that piece. Okay. So then again, we're just going through wherever you want to start. We'll put our little walker person here, and we'll go that way. So we're just taking 3x plus 9x plus 1x plus 5x plus 4x plus the one we already figured out, the 14x. Oops.
So you can do any of the like terms, so like 4, 5, and 9x, whichever are closer, correct?
Well, we did the 5 and the 9 simply because they formed, when we add them together, we get the bottom.
Oh, okay, because they're,
So that's,
oh,
yeah.
gotcha, okay.
So that's how we had to look here. And then what we really did take the 4 and the 3, but we had to subtract them to find this part. Okay. And so there's a little bit of problem solving in here. And it's good to kind of, work through it as an application, as an extension. And then there's some percent problems and such. But we're at the place, again, I'll show you. Let me just save this. Myself a new, oops, what's happening? So there's a few more expressions, and then there's a U try, and then we're into practice problems, which means we're back to where we started. Okay. A lot of times I'll go to the practice problems first, but I could use either ones. These are very similar to what we were doing at the beginning. Just some more practice problems. You should have the answers to these in either the back of the book part, and again, we'll take a look. What we'll do is on Wednesday night, we'll take a look at maybe more of these complicated problems. This one's a good one, only because it was on one of our tests, and I'll look at the test too and see where we're at. But they really stretch you a bit, and then we're back to application. So these are just similar problems to the ones we've already worked. And this is what I mean, the extension problems. Some of them get a little bit wild, but it's okay. Again, if you'd like to prepare yourself, especially if you're going into the science-based field or something, I'd be happy to help you out with these. But otherwise, don't worry about it. And extensions are just that. There's this review part, which sort of serves as like a quiz. Again, just another resource for you to kind of review things. So it looks like we did a really good job of at least making it through the content the first time. So what your job is now is to kind of work through some of these practice problems if you can. Or, yeah, here's the, well, this is the you try problems. I'll track them down. I've got the answers somewhere to the practice problems. I don't think they're in here right yet, so I will get those lined up for you. And so your place to go is the online homework, or if you're feeling fairly confident about things, you could jump to the online quiz, but both of them will kind of test you out if you're ready. The online homework does give you more practice, which is oftentimes good, because sometimes once you learn something, it's at a certain level, but if a strong wind comes, it sort of blows away. And the more problems you work, the tighter it is in your possession. And so you'll remember it more. So that's why I suggest the homework problems. The quiz, as you'll see, is shorter, fewer problems, only 10. And if you do well in it, it does show you know it. But then just test yourself. You know yourself, where you're going, what you need to do. Again, I don't want you getting bored just working a lot of problems that you already know, but I do want you learning it. And even with this, what you can do, even ones that maybe you kind of knew, once you finally get the right answer, once you put something in, you can always rework a problem. You can always ask for a similar problem even after you've finished one. Just to get the practice. And oftentimes all it's doing is it takes the same problem but randomizes the numbers so it makes it a little different. That's a way to get some extra. And some of you may do that as we get closer to the first test. You might want to go back on some of these and rework them, and you can do that. It's review problems. Okay. But other than that, there's a media lessons. Remember.
Does it have any today?
Good question. Let's go.
Does even the first one?
Not in the sense that you're going to lose any points after a certain date. There's no kind of dates like that. What we do in this class, let's see if I am in the right place. Let's pull this up. This over here. It's kind of the suggested pacing comes from the syllabus.
We do it at our own pace.
Yes, sort of. So where we're at today was Unit 1 and 2. We really got through Unit 2 really well. So Wednesday's unit is going to be mostly going over a few more problems, answering questions. You know, it might only be 20 or 30 minutes that I'm up here, and then we're working on some problems. If you work ahead and you get through it and you feel comfortable, it's up, you know, you don't really have to be here in class unless you've got some questions, but that's a good time to get some questions. 3, and 4, then we're into review really by, what's this, February 19, 2021, we're taking a test on it, right? So we've got an exam, that's when you should be ready. If you get to that date and you're not quite ready, hopefully it's because you've been working on it, but it just hasn't been speaking to you or something. I'll work with you because I'd rather you take a little bit more time to do it, but that's sort of our goal. So if you feel like, yeah, if you haven't done lesson 1 or 2 yet, that's okay. You have some time, but just kind of follow this schedule. You know, we've got another day for 2, so you work it in your schedule. Yeah, you pace yourself through the schedule, but each week, you know, try not to get more than a week behind, because that's harder to pick up on. But you know, I know things happen. You know, illnesses, family issues, work. Those things. You pace it out, though. You know kind of where we're headed, and there's no strict due dates like after this date you lose so many points or something. No, there's never anything like that, and I'll always keep working with you. But then there comes a point where, yeah, just there's a time to learn and there's a time to learn, right? So, and you know that, you know.
And every weekend you grade if everyone's got it done.
I typically do. I haven't entered anything into the grade book yet, so this weekend I'll take a look back and start putting some things in there.
And if you're not finished with Unit 1, you can still.
Oh, sure. Yeah, you can finish it at your pace. And I think it's a good way to go through is not to necessarily try to finish everything, but maybe try to do, work through by doing half the problems, do the evens or the odds so you can get the full lesson. Mm-hmm. Remembering when you get down to the last part where there's applications, I'm not so concerned about that. I'm more concerned about the skills part, the early part. So do well in that part, the applications, dabble in them a bit, and then go back and work the ones you didn't. You know, if you work the evens, go back, do the odds. You'll get through it. Okay, and about 85% gets you complete. So there's more problems in there than you need to work. But
if you get them all done, is there a little extra credit?
There is. So if you're getting up above 90%, then yeah, you'll get some extra credit thrown in there. I can't remember for this one, but yes. So if you want to, you know, if you go to 100%, you'll get rewarded. You'll be fine. And the thing is, if you go that far, you'll understand it well too. Okay. Awesome. Well, I think that's good. We still about 25 minutes in class. If anyone wants to stay and work through some things, I'm going to end the live stream now. So thank you for those who have been attending. We appreciate your attendance and have a great day. Remember, word of the day, achieve. Okay, achieve.